Alright, so today we're going to do an introduction to simple harmonic motion. That's what SHM stands for. We're going to talk about some example problems and some ideas that you guys might give me about what you think simple harmonic motion is. So to start with, what is simple harmonic motion? Simple harmonic motion is simple repeated motion either with respect to horizontal movement or vertical movement. The reason we're going to keep this simple, and we call it simple harmonic motion, is because we're not going to do any combination movements, things that are moving at odd vectors, none of that stuff. So you may have heard of simple harmonic motion in other classes, but we're going to keep ours simple. We are only going to look at horizontal movement or vertical movement. That's it. So if you look at the clock pendulum swinging here, it's just going to keep going back and forth. It keeps going the same amount of time. Same thing with the yo-yo that was spinning there. Okay, so simple harmonic motion is observed with respect to the midline of the motion. So if we look at the grandfather clock, we have the midline. Okay, that's going to be the x-axis. And the x-axis here is going to be what happens, how far you are from the midline with respect to time. So as that pendulum swings, I want you to see what's happening with the graph. So there we go. Come back, it hits the midline. So if you think about it, right, we were far, far away from the midline as far as we're going to get. We swing over, hit the midline, swing across, again, get far away from the midline, back to the midline, back to where we started from. Folks, this is a great example of a cosine curve. Okay, you started away from the midline, so far away as you're going to get, and then hit the midline, swing away, hit the midline, swing away again. Okay? So, cosine graphs, you're going to start off center or off the midline. If you are talking about vertical movement and you start positive, it means you're going to start above the midline. If you start below the midline, that's going to be negative. For horizontal movement, if you start to the right, you are going to be considered positive. If you start to the left, you're off the center. I can't talk anymore. Hold on. If you start off the midline to the left, that is a negative cosine curve. So we've drawn all these cosine curves and sine curves in the last unit. There's the negative cosine x. And if we start high off the midline, that's going to be our positive cosine x. Sine is very much the same, only the difference would be it starts at the center. So if you start vertical movement at the center and then go up, that's going to be positive sine. If you start at the midline and then go down, that's going to be negative. For horizontal movement, you're going to start at the middle. If you move to the right as your starting movement, that's going to be positive. If you move to the left, that is your negative sign. So there's our pretty little negative sine x. Remember, these are both going to start at the center or on the midline and either move, for positive, it would move up or right. For negative, it's going to move down or left. Okay? Now, so I want you to put the animation on. You're going to watch the little killer whale jump around. Okay? It's going to keep going, keep going, keep going. Now, one thing I want you to be careful about. While you're going to look at this and say, oh, Ms. Kern, this looks just like a sine curve. It does. That does not necessarily mean that you have simple harmonic motion. I want you to think more along the lines of a killer whale moving up and down. All right. Yes, it's jumping up out of the water. It hits back to the water, comes below the water, back up. All right. So where is this particular killer whale started? It's starting at ocean level or at the midline. It goes up. So if it's starting on the midline, that's sine. If it's going up, that's going to be positive sine. All right. So it starts positive. All right. So we've got another problem here. Tom paces back and forth as he ponders what to buy his wife for her birthday. Which equation does this depict? So think about where Tom starts. All right, and we're going to set Tom in motion here as he's thinking. He's thinking maybe he could get her some flowers. No, that's not good enough. He's going to get her some chocolates. Hey, that would be nice. All right, he's just moving back and forth and back and forth. Yeah, he didn't think of anything in that case. Okay, oh, how about a puppy? All right, so this is that repeated motion. He's going from the left to the right, to the left, to the right, to the left, to the right. Okay, that's the repeated motion. He's not walking across the floor in a sine or a cosine curve. He's just pacing back and forth. Since he started on the left and then he moved to the right, he started off center left. That is a big old negative cosine curve. Okay. Little amper trig roller coaster here. Again, this is an example where it's going to look a lot like the curve. Okay, it's moving up and down, but think about it in terms of where's your midline and where are you moving to. Okay, so midline is right across the middle of this graph. Okay, I don't know if you can see my cursor moving. I kind of hope you can. And immediately this amper trig is dropping below the midline. So it started at the midline, drops below. That's going to be negative sine. All right, so here's a little x. All right, I want you to watch the movement of the x, and I want you to think of what equation could depict this motion. Remember, we're either going to be talking about vertical motion or horizontal motion. We don't have circular. Okay, so little x is spinning. Spin, 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 spin. I think it goes again. All right, so if you thought about it, all right, how many of you thought it was going to be negative cosine x? Well, negative cosine x would be if you're looking at this movement from the left to the right. So this x right now is in the farthest left position it will ever get to, and as it moves, right, if you watch the little green line across the bottom, it goes all the way to the right and then back again. Okay, so that would absolutely be an appropriate graph to talk about the horizontal motion of the x. Anybody say sine of x? And if you did, that would be a prime example of vertical motion. Okay, the x is starting in the center. It goes up to the top, back to the bottom, and then back to where it started from. So both of those are great examples of what's going on with this particular problem. All right, so quick little sample problem. Brady does push-ups to impress the girls in his gym class. He begins in the up position and does 5 perfect push-ups. What is the equation that describes his vertical movement? Well, his equation is y equals cosine x. He is starting in the up position, all right, and when you do a push-up, you're going to go from up to down and back up again. Okay, so that's off center, moving, he started up first. Okay, if we wanted to create a new equation, y equals negative cosine x, what would we need to change in this original problem to make that happen? Well, to make it be negative cosine x, he wouldn't want to start in the up position. You would need Brady to start in the down position. So if we start Brady in the down position, that will create this new equation of y equals negative cosine x. Right, and Brady can do some more push-ups there. All right, so clock shows 4 o'clock. The clock's minute hand completes a full circle every hour. Remember, the minute hand's the longer one of the two. The equation below is given from the horizontal movement of the tip of the minute hand. So if we look at the horizontal movement, all right, tip of the minute hand's right here. Horizontally, this is going to move to the right, back to the middle, to the left, back to the middle. That is absolutely a sine curve. It's starting at the middle, and it's moving to the right. Okay, so what I want you to think about is there a way to make this problem have a new equation of y equals cosine x? All right, take a second, think about it. And there are 2 ways to do this. All right, one of the ways to do it is to talk about just simply changing it to vertical movement. All right, vertically moving it, we can look at the tip of this minute hand here, and it's going to move up and down vertically as opposed to side to side. All right, so that would be your vertical movement. The other way to do this is, instead of letting it be 4 o'clock, just make it 4:15. All right, if we make it 4:15, then the minute hand is at the farthest right position it'll ever be, and it will move to the left and move back around. All right, and that would be your new equation of y equals cosine x. All right, so last problem we're going to talk about here is actually a sample problem where we're going to take a situation and turn it into an equation. We are going to then graph it as that trig equation. So Mr. Wallach rides the Ferris wheel with his wife. It takes them 30 seconds to complete one turn, and the distance from the bottom to the top is 150 feet. Write the trig equation that depicts their vertical movement and graph it. So first things first, we're talking vertical movement. All right, so we need to think about where this x is and the fact that we are starting off center low. If we're starting off center low, then we should be thinking about, I'm going to let this x finish its full rotation here. Keep going. There we go. Determine which trig function to use and the sign. So if we're talking off center low, we need to be thinking about negative cosine x. Okay, but we need to then change the amplitude and change the period to make it fit this particular problem. Okay, determine the amplitude. Well, it says the distance from the bottom to the top is 150 feet. Well, that's nice, but remember your amplitude is from the midline to the maximum or midline to the minimum. So I want you to take that total distance, chop it in half. All right, so 75 would be from the middle to the top or middle to the bottom. The last step is to analyze the period. It takes right now 30 seconds to complete one turn. Well, one turn would be one full revolution, one full cycle of the graph. Remember, it's 2 pi divided by some value in front of x. In this case, it's written as an n. And we want to make that equal to 30. So if you solve for n, you would end up with 30 over 2 pi, or how about 15 over pi? Oh, I got it backwards in my head. Pi over 15. Sorry about that. All right, so that's our equation to get the period that we need of 30 seconds. Okay, and the last thing we want to do, there's our equation, we're going to graph it. So keep the period simple, keep the y-axis simple. We're going to label positive 75, negative 75. Remember, our farthest time was 30 seconds, so go ahead and label those across. 7.5, 15, 22.5, and 30. If you had fractions, that's totally fine. Started off center low, midline up, midline down. All right, so that is one of the things that you guys are going to be doing, is looking at problems and turning them into trig equations and then graphing them with respect to what the problem actually gives you. One thing I will tell you right now, this graph is missing. We should have the axis labeled, so this would be time in seconds, and we should have the y-axis labeled. This would be the distance from the midline in feet. Okay, so the last thing we're going to do is going to be to lead you into your actual discussion post for today. I'm going to pop a discussion post into Canvas, and I'm going to ask you guys to think of a simple harmonic scenario. Okay, keep in mind the word simple here. Simple harmonic scenario that could describe either graph shown. Okay, so this top graph, you have a sine curve, which means it's got to be starting at the midline and then immediately going down, which means this is going to be starting at the midline moving left or starting at the midline moving down. And then for your bottom equation here, your bottom picture, not equation, you are starting off center positive, which means we're starting off center either on the up or off center on the right. Okay, so that's going to be the discussion post. You guys post what you think could work, comment on each other's thoughts, and we're going to keep talking about simple harmonic motion.